All right, yeah. Hello, everyone. It's good to be here, and I guess I owe you guys a secret origin story. So, as with many MIT people, I got my start in Bitcoins by using MIT's electricity to mine Bitcoins. Back when I mined my first Bitcoins were worth about $1, and like many reasonable people back then, I took those Bitcoins and I bought pizzas with them, and I was really proud of it because I was a poor-ass undergrad and I was using MIT's electricity to buy myself lunch. Those pizzas are worth about $1 million each now, and goddamn it, I bought a lot of pizzas. So it's a lot of pizzas. It's like $100 million worth of pizzas. The next time I did it, I used MIT's electricity to mine Ether back when Ether was like $50, and that time I kept it Ether and used cash to buy pizzas, which was a much better deal overall in the end. But it's a common origin story that you'll see at MIT. It's the reason why we gave out 1,000 Bitcoins back in 2013. To us, those Bitcoins were all free. We mined them with MIT's electricity. We wanted to shore up the ecosystem. And it was kind of cool. I met someone at CSX who got their start in crypto because we gave him a third of a Bitcoin, and he got interested, and now he's a CSX founder and a CEO of a company. So we did something good there.
They probably don't know what CSX is.
Oh yeah, CSX is the A16Z crypto seed fund accelerator thing.
So as you guys can tell, it's not going to be very hard to get hot takes out of Bayley. So hopefully that was burst of money. I'm also going to not use a microphone because I hate that go unless anyone wants me to.
I don't think we need a microphone.
Okay, yeah.
We'll do micless for this one.
Awesome.
Yeah.
Wait, let's turn that off. Okay, so Bayley, I would love to, I know you mentioned that you got your start at MIT. Would love to hear the origin story now for how you got into robotics, what specifically interested you, and then what were you working on in robotics before you decided to join the crypto space?
Yeah, so I got my start in robotics at MIT in the sensor and planning space. I worked with the lab that did the MIT team for the DARPA Robotics Challenge, and some of you guys might remember the DRC. It was a challenge where you had to go build a robot, and it had to complete a series of search and rescue tasks, because for some reason that's what DARPA thought was important back then. And it was interesting because the resulting concoctions were unearthly. They were these contraptions built by research labs. There was a joke that one of them had so many wires you couldn't actually see the robot. It was just a pile of wires. And the winner ended up being some sort of as you would expect, not a humanoid, because this was 2013. The thing that won the challenge was a super specialized tool that was designed to exactly fit through the slots and holes in the DRC and win the competition. And back then, the industry was in a much worse state. You just couldn't buy a robot. The only non-industrial robot you could buy was the SoftBank Pepper, which wasn't really a particularly hot piece of hardware. And we worked, the MIT team and a couple of other teams got donations of the original hydraulic atlases, which were from Boston Dynamics, which were possibly the worst robots I've ever touched, combining extreme weight, utter lack of control, and leaking hydraulic fluid at high speed. So as you tried to do your research, the robot would be spraying warm hydraulic fluid at you out of its high pressure joints. And then what really made the modern industry take off, I think, was our work in 2017 on the Mini Cheetah. It's like a depressing name. It's just a small and bad version of the Cheetah, right? No, the Mini Cheetah, what it really solved was the actuation problem. We took the $1 billion that had been dumped into the drone industry building drone motors, and we retooled the manufacturing and the parts to build power-dense robotic actuators. And that got the cost of the actuators down from about $10,000 a joint down to $200 a joint, which is a big deal. But more importantly, it showed the world that electric actuation could work. If you go actually do good engineering in the absence of any product considerations, electric loses. It's not as force dense as hydraulics. It has idle losses because of motor resistance, but a lot of things came together, and the 6-to-1 gear reduction ratio electric actuators ended up being the right parts for the product. And because we had those actuators, everyone started building robots, and now robots look like what you see today. There's 100 vendors that you can buy a cool robot from.
For people who are not as up to speed on the progression in the robotics space, can you talk through one or two of the robots do you think were really impactful to where robotics is today?
Yeah, I think Pepper and Now from SoftBank were important because they were the first attempt to sell a robot in a space other than a manufacturing line. Boston Dynamics' Big Dog, the hydraulic quadruped, was also really influential because it showed the world that you could do interesting things with a robot and like really good active controls. Then, of course, Atlas. Atlas was a pioneering humanoid that showed that humanoid robots were possible. And I worked on the robot, so I'm biased, obviously, but Cheetah 3 and Mini Cheetah were really important in shifting the industry from research to product. And I would say an even lesser known set of robots were the original MIT Leglag robots from Mark Graber, the BD founders lab back in the mid-90s, which used a combination of crazy ad hoc hardware and crazy ad hoc software to do things that to this day we have trouble replicating. Like, we don't really know why or how those robots work so well, but a bunch of grad students got together and did a lot of really good experimentation to make those robots work.
So you mentioned that we're maybe more towards the product phase of robots than the research phase. What are the hurdles left that we have to overcome before we'll see tons of robots out in the world doing, personal, commercial, or industrial use cases?
Yeah, so I think the hardware is largely a solved problem now, at least in the sense that it's not the hardware that's holding back the commercialization. Good AI, more specifically good task completion and planning in an end-to-end way, which is very robust to new environments, is one of the biggest barriers right now. That's one of the things that PrismaX is working on. That's one of the things that a lot of the other projects and companies are working on as well. Beyond that, if you wanted to really zero in on like something that's left in hardware, I would say manipulation is the other hardware hurdle. And I think that is going to be solved in a variety of interesting ways. Building like this hand is probably not possible with like mechanical parts because we can't build muscles right now, so there's going to be a combination of tools. But I would say that the one single thing really is like good task planning, task completion, and environmental interaction with enough nines of accuracy that you can ship it in a product.
Can you talk through what PrismaX is building?
Yeah, so in order to ship these robots, there's going to be a core flywheel which enables commercialization. Right now, in order to put a robot in the field, you set the robot in the field and you have someone remote control it. It's called teleoperation if you want to be fancy, and it could be as simple as a browser interface or as complicated as AR, VR, or an exoskeleton. And what this does, it allows you to go to market now using sort of like labor arbitrage business models, and then collect data in the hopes that that data will drive better AI models. So that is the core flywheel that PrismaX services. We're building infrastructure to allow decentralized teleoperation at scale. That allows these operator fleets to scale much faster than any centralized project can. A decentralized project can scale to 10,000 participants very quickly, for example, whereas centralized projects have a lot of time hiring 10,000 gig laborers to go operate the robots. And the data captured by those teleoperators is returned to the network to build better models, and those models make teleoperation more efficient, which enables more users, more data, and even better models. And the reason why we're doing it in a decentralized way is really this core idea of scalability, right? In the end game, if you want robots to actually be successful, you're going to need 1 billion robots, and you're going to need, tens or hundreds of millions of operators to go handle things like getting the robots out of sticky situations, collecting data, scaling data across multiple environments. And it's just not reasonable to do this in a centralized way. It would be like trying to go build the internet by paying people to write down all of the information in the world. Like, there's no internet company, there's no Bitcoin company, and there should not be a single central entity which goes and dispatches and manages all of these robots.
Can you talk us through the types of data and specifically training data that you think would be most valuable in this network?
Yeah, so right now, robotics companies typically do embodiment-specific or like few embodiment approach to training their models. They go collect a bunch of data on their robot, usually in a specific set of environments, then train a model that allows the robot to autonomously operate on those tasks in those environments. So that's the thing we're starting with, because there's a strong fit, like how operators go interact with existing hardware to collect data. The model companies, robotics companies pay for those services to build models for their robots. It slots cleanly into their current business models and replaces something that they're paying for and have a lot of trouble scaling, hiring these operators. On the long term, in order to really scale, it's like there's a camp, including ourselves and NVIDIA and physical intelligence, that really believes that large-scale visual data is the only modality which allows you to scale models to full generality. So that means a robot that works as well in this room as it would in a factory with that kind of cross-domain generalization. And it's not that visual data is better, it's that it's not possible to bootstrap the other data modalities without having the robots first. But you can't go bootstrap out 100 million robots that don't do anything but collect data in order to collect the data to make those robots useful. Like, the economics don't work out. So passive visual data collection at scale was what's going to enable the bulk of that intelligence. And then there'll be like additional fine-tuning on specific hardware in order to build better robot models.
We've seen centralizing forces influence the AI space over the past 5 years or so, and large companies emerge. How do you imagine open source to influence the robotics space, and what types of things will be standards or shared across companies in a different way than they are in the AI space?
Yeah, so robotics is a little different from AI because it's traditionally already very decentralized, right? Like, the bulk of progress in the past 10 years in robotics was done at mostly academic research labs, plus one moderately sized company, Boston Dynamics. Like, that was the bulk of all the advanced robotics progress you see today. And I think that can continue. There's already a culture in the space of cross-team collaboration, standardization, and I think that will continue if we set the right path on the industry. In terms of a business model, I think robotics is better suited for openness and decentralization because you don't need the $10 million to go do the model training. Like, every time you train a foundation text model, you burn $10 million in GPU costs. And because the models in robotics are a lot smaller and can get a lot done with fewer parameters, we don't see that being an issue. So I think there's an opportunity for a lot of standardization. In terms of what standards come out, I think one of the big things is going to be harmonizing the user experience for teleoperation. Right now, there's about 100 companies that are building 100 ad hoc user interfaces and trying to hire people to do this. And that's just stupid, right? Like, you don't get good UX, you don't get people who are well practiced on these things, and being able to standardize that and standardize compensation is going to be a big driver force in being able to make things move forwards. And other things too, like how models interact with hardware, how we generalize models across embodiments, are all things that open source can help build.
Are there other approaches or use cases at the intersection of crypto and robotics that you're excited about that you guys are currently working on?
Yeah, let me think about this one. I think there's a lot of opportunity for more transactional projects that focus on either inter-robot collaboration or like robot-to-robot transactions. Robots are sort of like physically embodied agents, and unlike the software agents, there's a clear use case for the robots, right? Like, if you could build a robot which worked well, people would pay for it. Whereas building an agent which automatically books you a hotel is a very questionable use case, because booking hotels is like not a major barrier to my happiness in my life. Maybe it is for some of you, but it's, I think, not typical. So I think working on the more transactional mechanisms is interesting. It's a little more forward-looking because we don't have enough robots in the field. But if you predict the future and you want to put a stake down, I think that's also very interesting.
Okay, 2 more questions. Are there any upcoming releases in the robotics space that you're excited about and we should be tracking?
Ooh, I know some insider information.
Not insider information.
Yeah. Let's see. Keep an eye out on the big robotics research, what I call big commercial robotics research labs. Some of them are making interesting moves and seem to be taking the right path. So the companies like Physical Intelligence, Skill, World Labs to some extent, whatever Bayley is doing these days. I think that's going to be very interesting. Otherwise, I think there's going to be a lot of good progress on manipulation this year. A lot of companies have converged onto the same problem in the hardware side, that manipulation is annoying. And I think there's going to be sort of what we call the mini cheetah moment for manipulation this year, that hands are going to, when this is all said and done and the dust settles, hands are going to cost $800 instead of $8,000 and will work a lot better.
I don't really know what the contentious topics are in the crypto and robotics space, but are there any points that the various companies disagree on that you could potentially have a hot take on to share with us?
Yeah, the number of legs your robot should have. Depending on how many legs your robot already has, it's like the right number of legs for a robot is definitely the number of legs the robot you're showing to the investors has. So if you're a humanoid company, it's 2. If you're a quadruped company, it's 4. If you're that one horrible company that builds centaurs with the safety feature of doesn't fit through doors, it's 4. And if you're, in my opinion, reasonable, the answer is 0 or very close to 0 for now, because the robots have enough trouble not dropping objects without also dropping themselves onto the ground. Not having legs also makes the robot 3 times cheaper. A leg roughly costs as much as 2 arms, right? So you get 3 times. I would rather have 3 times the number of robots. In fact, I would argue even if I didn't have stairs, I could have 3 times the number of robots. 1 set for each floor of my building, and I would when within reason, unless my building was a skyscraper that had no elevators, which would, you have a different problem there that the people aren't going to be very happy either.
So you're pro wheel.
Pro wheel, definitely pro wheel, which is strange because I worked on legged robots, but perhaps the reason it's because I worked on legged robots that I don't like legs very much. And I think a lot of the people who used to be serious in the legged robot space would agree with me right now. Legs are cool, but they're not the problem we need to solve.
All right, not the hot take I was expecting. I'm going to open it up to the audience in case anyone wants to ask any questions.
I like to ride my bicycle more than running or walking. Yeah, back to
Pro
the bits. Yeah, but what do you think about self-replicating robots? How far away we are from that?
That's a good frontier question. I actually think we're not very far. You could do it. The question is, it's unclear whether this actually solves a problem. I could go build you a robot and an AI model which allowed the robot to build itself, but the robot will only build itself. We still don't have the software to then take those robots and get them to do things in the wild, so I don't think we solved the real problem.
What about for applications where there's high latency? So say like we want to make a base on the moon or on Mars, and we want robots to do that.
Not a hypothetical question, by the way. They're actually working.
Yeah, it's a very reasonable question. I think there are 2 approaches. One is the train an AI model which goes and does latency compensation, either by predicting forwards the video feed or predicting sort of backwards the actions. The other is people are really good at picking up latency if you let them practice enough. Like the neural network in your brain is a very powerful one for stuff like this. So I think it's going to be a combination of the 2. To me, it's a UX problem, not a technology problem. Like you need to build up the right UX which balances versatility with intuitiveness and latency. I like moon robots. You should come talk to me afterwards.
So you mentioned decentralized a couple of times. Are we talking about decentralizing the ownership of the technology, like open source, or were you talking about some other type of decentralization?
Yeah, that's one aspect of it. Like in this context, decentralization typically means coordinated by a cryptographic protocol that achieves consensus without having to have trust. But in the context of robotics and AI, I think a strong aspect of it is having open access to the weights and to some extent the training data within reason. I think that's important because the model weights as well, right? Like the issue with OpenAI right now isn't, it's like people will complain, oh yeah, OpenAI is like censoring this or censoring that, but what actually OpenAI is doing is they're catering to a minimum legal liability denominator where because they're worth $200 billion, they're obviously a target for litigation, so they can't do anything that would potentially create any sort of controversy. But the world is not controversy-free. Like people disagree and they have different use cases and there are different cultures. So trying to cater to like the thing that every single person agrees on creates a product which isn't that useful for anyone. And having more decentralization reduces the size of the target you painted and allows people to be more flexible in what they can do. My friends in like the open source text model space would agree with me that ChatGPT is way too polite, and like it's like polite to the point where I want ChatGPT to write an email, it just can't because the RLHF has removed all semblance of starters from this model in order to avoid people complaining. It's a product I want, but it's not a product OpenAI's lawyers will let them build.
Yeah, I wouldn't sure if you meant like communications or that sort of thing.
More questions?
What do you think about energy for robotics? Like, for example, how far are we from nano robots?
Nanorobots and energy seems two separate questions. As far as energy is concerned, I'm like 100% on board with Elon that solar is the only way forwards. That alone is a spicy take somehow. As far as like self-replicating nanobots and gray goo, I think that's quite a ways out. Nanotech is one of those somewhat cursed industries where it's like not big until it becomes big again. Then everyone starts putting money into it, but no one really knows what's going on. And then the bubble collapses a few years later. Like the current gray goo like nanobot thing came out in the early 2000s. We had like gotten semiconductor fab technology good enough that people were like, oh yeah, we can go do this gray goo thing that I read about in a sci-fi novel from 1970. But we were far away from being able to do that. I think it's 2025, and I don't think we're actually that much closer to being able to build a good nanobot.
Yeah.
Sorry to disappoint.
I think the main problem is battery storage, right? Like, so still the energy for
I think
nano.
there are so many problems to building nanobots. Like, it's the best nano machine I can build you right now is like a stick which does this. And using this mechanism, you can build gyroscopes and accelerometers and all kinds of other useful things. But getting a really complicated machine is challenging. I used to do fab work, and like building a stick which does this is like a 80-step process which requires precise control of every step and about $6 million worth of equipment to do. So building like a tiny person is going to be challenging.
I love when you're talking about the legs, right? The
Yeah.
debate and the number of legs. Is there a similar debate amongst the hands about the number of fingers?
Yes, absolutely. The right number of fingers is obviously the number of fingers that your product has. But realistically, it's probably 3. It's like the minimum number of fingers where like if you do like this, you can do a lot of things. You need an opposable thumb. Maybe it's 2. Some people say it's 0, like just attach the tool to the robot, like why the hell do you need hands? Some people say it's like a vacuum cup. But that's something that I think will get solved in the next 18 months. Like we'll have a consensus on what the right number of fingers is and what the manipulators look like.
What's the timeline for consensus on legs?
I mean, it's already been done. People who used to work on robots are saying that it's wheels and knees and deal with the legs later. It's just that there's Figure has put a lot of dollars into building a robot with legs to create a demo video where the bottom half of the robot isn't even visible. So that should like tell you how useful legs are. Like Figure's 1 hour like flagship demo video does not show the bottom half of the robot.
How long do you think it'll be before they have open source kits we can program to send out to help people in the home and do things for elderly and stuff like that? That are safe.
Open source kits that you can program are safe probably within a year. Robots that can go into homes, 10 years. I no longer answer that question because I used to say 5 years, but then someone very smart told me that I was way too optimistic. So I no longer really answer that question. Houses are really annoying. They have just enough steps that you do need legs. Every house is different. Your customers are like not that good in technology. Like if I go set a robot in the same room as grandma right now, I'm not sure what would happen, but I would probably neither have a grandma nor a robot. So it's gonna take a little bit of progress. It's gonna take a little bit of progress to get there. I think we're gonna see limited home robots for things like cooking, laundry, in 3 to 4 years, maybe like companionship as well. But actual like a single robot which can roam your house and do everything is a bit of a ways off.
I think we had a question back there first.
Yeah, so I was wondering in the case of decentralized SLAM sharing or whatever the terminology is, that sort of incentivizes decentralized publishing of information from sensors. How do you sort of balance the privacy concerns of publishing that information if the token economics behind it, incentivize that data to be shared? I guess where does the balance fall?
I think it's the same as a lot of the other like deep-in type AI wearable meta glasses AR VR thing, that it's a pact between you and the people around you, how big of an asshole you want to be, and you pay not in cash but in like friends. You can go become the most hated person in your town and get like kicked out of every building and try to sell everyone's data, but you're not going to be able to do that for very long. So I think it's going to end up being a matter of respect. The way all of the deep-in protocols run right now is that, including ours, is that it's all opt-in. Like you collect data, you opt it in, and there is a little bit of sensitivity around what if there are other people in the video. But I think that's like taking videos with your phone, like posting stuff on Instagram. It's going to be solved through community and through, like, if you're in a private building, the owner of the building can say no, you may not capture video in my building. That solves it. Back when I used to work in like AR, VR, people would ask me this all the time, and there the answer really is just like, people should not be assholes, and if people are assholes, they will have no friends.
I guess that also stops whales from like working robots for fun, right?
Yeah. I mean, so bricking robots for fun can be solved at the protocol level by building in mechanisms to detect bad behavior. You can either, it's as simple as like voting, or as complicated as using AI to go look at what's going on. But you can make it to the point where people are highly disincentivized to go just crash the robots into the wall.
Makes sense.
Also, yeah, because they're in the physical world, there's like the whole real law enforcement.
Yeah,
They can step in
like
as
you
well.
can't go beat people up with the robot and get away with it. It's unclear what the law is for that right now, but something's gonna show up in the news soon. I bet, like man controlling robot like commits robbery, who's guilty?
Well, I think
So I read that Amazon and also like Unitree, they've already been using like big power wireless charging.
Yeah.
Do you see it? This would be like the optimal charging way for robots in general? Because I think if like it were okay, I think with like wireless charging, there could also be a deep-in company that's like selling the like wireless charging devices to people that people can own, and then also like do mining.
Yeah, the type of wireless charging you're talking about is like closely coupled inductive charging, similar to how you charge a phone. So the robot like
big power.
the robot just like squats down over the charging pad and gets charged. It's a great solution because it eliminates a lot of like the waterproofing problems surrounding charging contacts, but fundamentally it doesn't enable a new use case. Like it's not like the robot wanders around forever and is being beamed power. That just doesn't actually work. There's at least one company doing that, and I think they're from MIT, which is embarrassing, but they're like a good scam. They claim to have come up with some sort of phased array radar system that allows you to wirelessly track and charge your phone, but in practice they like can light up an LED briefly at 30% efficiency. But to your point, I think that type of charging pad will probably become the standard because it's cheap to implement. There's a lot of other use cases for like EVs and stuff.
Right.
Truly remote power, maybe it'll happen through like optical links and lasers and stuff, but like there's many obvious practical issues surrounding it that may or may not ever be solved.
Do you have any hot takes on exoskeletons?
Yeah, I think they're great if you want your knees broken. I love exoskeletons, and it's like, I think if you wanted to start a hardware company in the robotic space right now, exoskeletons are not a bad thing to tackle. There's like outside of like whatever DoD use case, there's a clear use case for selling a device which gives people this older people the strength they've had when they were young. Like people pay for that, right? Like it's practical, and people don't want to admit that they're not as strong as when they were young. But the issue, I had like an in-depth discussion with one of my former Cheetah teammates a few weeks ago, and the conclusion was it's not the exoskeleton, it's how you transfer power to like this fleshy mass. Velcro straps don't actually work in the long term for a lot of force. You chafe real quick when you're like applying 2 arms of worth of force to your arm through Velcro straps. And otherwise, the answer is like you could go attach titanium bolts to your bones, but this is very painful and the seal is not very good, so you get like all kinds of problems around the flesh metal transition. But I think it's a really good field that if you want to go build a robot startup, this is not a bad field to play in. Not enough people are working on it right now. And you can sidestep a lot of the software problems because the fleshy thing underneath the skeleton controls the skeleton.
I have, for example, let's assume I have 3 talented robotics engineers, and I would like to start a robotics company today.
Yeah.
What's the hottest company in robotics space I can start?
The hottest or the hardest?
The hardest.
The hottest?
Hardest, yeah.
Hardest.
No, not
Hottest.
hardest, but hardest.
Okay. Ooh, what is a good company to start right now? I think something exoskeleton or human augmentation, I think, is a good unexplored space. If you wanted to just like go raise money, the answer is clear. You go build a universal humanoid, hang 3 like X whatever big project people on it, and then go ask for $50 million, and then pray that someone is fool enough to fund another humanoid in 2025. And I think they would if your engineers were good enough. But in terms of like actually being able to ship a product, I think like exoskeletons or something in a good vertical space. Food service is a pretty unexplored space. Huh?
Agritech?
Agtech?
Yeah.
Agtech is hard. If you could build a robot which could pick strawberries, you would be very, very wealthy, and you would solve a lot of problems that society currently faces. But the problem of picking a strawberry without crushing it has been like an unsolvable problem. My understanding is that the strawberry industry works according to very tight margins, so they refuse to accept 10% of the strawberries being crushed, and that like creates a lot of problems. I knew a company that was building a strawberry picking machine once, and it was not what you expected. It was like a 40-foot by 40-foot contraption which rolled over the strawberry fields using a series of small grippers hanging off the sides to go pick up the strawberries. They raised like $5 million and like immediately ran out of money because they were building like building-sized rovers with strawberry picking arms on them. Like $5 million gets you like 1 rover.
Can you elaborate on what you were going to say about the food service?
Yeah. So food service is interesting because everyone eats, and food service employs a lot of people. Something like the pre-COVID statistic was 30% of the U.S. workforce is employed in some way or the other in food service. It's not enough people are exploring it because it's not shiny and it's not heavily B2B. Like there aren't many big franchises you could target, but I think that there's a good market up. And I think it's especially true. There's like already data which shows that if your restaurant has a robot in it, people will come eat at it just to see the robot. So I think that fits very well. You don't even need the robot to have good ROI or good efficiency. It just needs to like be flashy and do interesting things. Robots are also very precise, so potentially you could go like build interesting dishes around this hardware that would otherwise be very hard for human chefs to create. And you could have like you could combine it with like sovereignty and attribution and like some decentralization to like have people contribute recipes which run on the robots. And like there's all kinds of fun stuff you can do if you go tackle the space. But the sales problem is annoying because then you have to sell to individual restaurants, and at that point the VCs will be like, no. But with like with like I don't know, some other business model or some clever sales model, you may be able to make it work.
I've been building prototype for a trash collection robot. What do you think of that field?
Outdoors or indoors?
Outdoors.
like picking up litter off the streets.
Off the beach and off the streets.
Yes. It's
in the water.
It's interesting if you can figure out the economics. Like the problem with trash on the streets is that people seem to be unwilling to pay to get it removed from the streets. And I don't know that having a robot will solve it. Plus security becomes a big issue. But I think there's definitely a market. Like municipal waste removal is a thing.
And I was thinking like ocean plastics and stuff like that. That's really what I was designing them for, was to keep the plastic from going into the water before it gets there, instead of cleaning it up afterwards.
Yeah.
But I just don't know how to fund that.
Yeah. So we're right. It's the problem with environmental tech that the other end of the return cycle is weird. Like it's a thing that people need, but it's a thing that people aren't willing to really pay for right now.
What do you think about like synthetic data? Because you mentioned earlier about teleops and doing a lot of data collection. What about like in the area of synthetic data?
I think synthetic data is really good for stuff like manipulation and locomotion. It's probably it's less so for things like interaction and task completion, because in order to generate the synthetic data, you need to have a model which can generate a very diverse variety of world environments with very long and consistent temporal context. And I would argue that that model is like topologically very similar to the model which generates robot actions via diffusion. Like roughly speaking, if you can generate a video, it's easy to go follow the video to complete the task. Like decoding the video into a set of like force vectors for your robot is straightforward, relatively speaking. So I think it's a good thing, but it comes down to like which model gets finished first, the video gen model or the robotics model. And I think right now it's going to be the robotics model. Video gen went and they hit a wall where the videos are 5 seconds long and cost $1 to generate and usually aren't the right clip. So they have some PMF issues right now in that space. So I think robotics is probably gonna come out first. So certainly if the ecosystem were reversed, like it was 2040, we had just discovered robotics and we were all generating like TikTok clips with video models, then the answer would be clear, like just generate the environments, but we're not there yet.
Okay. Oh, I think we gotta end it. But we can
I will continue to exist if you want.
And we're gonna do demos over there if you wanna go see the robot and do things.
Yeah.
Thank you so much, Bayley. This
Yeah.
is great.